trig can be used for all sorts of things, but one of the main things you want to be able to do is apply your knowledge of SOHCAHTOA to applications. So we're going to do a few examples with that. Up here at the top you have your steps. You're always trying to find, in this case, a missing distance. These particular applications, we are not finding the degree measurement, but it is possible to still go through these problems in the same manner. Set up and label everything that you know and work your way backwards using inverses to find the missing angle. So it's not specific to just missing distances, but most of the ones we're going to do today are distances. When you're dealing with applications, there's two main critical points. Not just labeling, but also some definitions. For example, an elevation of depression. So here we have a horizontal eye level, and if you have to look downward to an object, that is going to be an angle of depression. Similarly, when you have a horizontal line, if you have to look up to look at another object, that's the angle of elevation. So for example, if you're standing at the top of a building and you're looking down at someone, that's an angle of depression that you are creating with your eye line. If you are standing at the ground, or if you have a spot on the ground and you're looking up, say maybe you're laying on your back and you're looking at a bird, that's an angle of elevation. So we're going to need that when we try to set up some of these problems. All right. So let's look at this first one here. All right, it's talking about Jose. And so you have Jose stands a certain distance from a pad for a rocket. All right, so let's just draw that. All right, so let's call this our little launch pad. And let's give ourselves Jose. All right, and so it says that after 1.25 seconds, the rocket is 240 feet high. So here you have a rocket that was launched, all right? And this is, 740 feet high. And it says the angle of elevation from Jose is 68 degrees. So we're not talking about Jose's eye line. It's just the angle from Jose to this rocket is 68 degrees. We want to know how far is the rocket from Jose. And now some of this is a little bit hard sometimes to decide what side they are talking about. All right. So sometimes you can be talking about from Jose to the ground, or the ground level. And if that was the case, I would want to ask you the question, how far is Jose from the launch pad? All right, so that's how far he is from the launch pad. How far Jose is from the rocket, I'm going to make that this angle right here, or this side, and call that X. All right, so how far Jose is actually from the rocket is that distance. And that's going to make sense also as we do some other problems, but let's just make that our standard. That if I want to know the distance from Jose to a certain point on the ground, I will talk about that in terms of the object itself. So Jose from the object is up here. Now you have to, once you set it up and label all your sides, you need to figure out which trig function you're going to use. I have an opposite and a hypotenuse. So I'm going to say the sine of 68 degrees is my opposite over hypotenuse, which means that to find x, I need to cross multiply. And then I'm going to put this in my calculator. Again, for this case, we're going to round everything to 2 decimals. And so I'll put that up here where it says solve. And so unless it tells you otherwise, let's just go with 2 decimals. Sometimes other directions will say more, but we'll use that for now. And so now you want to put that in your calculator. All right, again, my calculator allows me to put it in exactly the way I see it. But if yours doesn't, figure out what you got to figure out. So that would be 798.12 feet. All right. And so you need to make sure you always put a unit. All right, this little mark is the same thing as writing feet, but you could also write the word. All right, but that would be the distance from Jose to the actual object. So this is what you're going to be asked to do. All right, you're going to be asked to draw and label a picture, set up the trig function, all right, and then manipulate to isolate the variable, and then plug it into your calculator. All right. All right, so now it's talking about using that terminology, the angle of depression from the top of a building to the point on a ground is 54 degrees. So I need to draw my building. All right, it's kind of a narrow building. And I also need to draw a point on the ground. And so when they're talking about angle of depression, again, from the top of the building, that's kind of like the horizontal eye level. When I draw a point from the building, or a line from the building to the point, this is my angle of depression. All right, and so that right there is 54 degrees. Now you have something in geometry which talks about alternate interior angles. So when you have these two parallel lines like this, and you cut through it, we call it a transversal. Whatever angle is on this side is the same measurement as the angle on this side. And so I can label that portion also 54 degrees. All right, but it's important that when you're talking about angles of elevation and depression, that you first label which one they are referring to, and then you can use other geometry to label other angles. It says, how tall is the building? All right, so how tall is the building? If the point is 340 feet from the building. All right, so again, being able to label, see again, it's telling you specifically that the point is 340 feet from the top of the building. Oops. So how tall is the building if the point is 340 feet from the top? I labeled the wrong side. It said from the top, and I didn't label that. All right. So it didn't say 340 feet from the building, and originally when I read it as from the building. So when you're talking about the top of the building to the point, that's this side right here. All right. So again, being very careful, I had mislabeled it because I misread it. But again, we're going to be using sine for this. So the sine of 54 degrees is x over 340. And now in this case, to find x, I just need to move that 340 up to the top. And then I can plug that into my calculator. So 340 times the sine of 54. And so I get 275.07. And that is approximately how tall the building is, which is what it asked. Right. So be careful. Make sure that while you're working on these that you take your time and label the correct sides. Yeah. All right, so Kyle. Let's draw Kyle. I don't know what's going on with Kyle, but there's Kyle. It's 200 feet from the base of a flagpole. All right, so 200 feet from the base of a flagpole. All right. And so it says the angle of elevation from his eyes to the top of the flagpole is 32 degrees. All right, so from his eyes, I'm going to make a horizontal line of sight. And the angle of elevation is 32 degrees. It says find the height of the flagpole. And it says Kyle's eyes are 5 feet above the ground. So what that means is that this section of the flagpole is 5 feet. So in order to be able to find the entire flagpole, I'm going to need to use some trig to find this top section of the flagpole, and then I can add that to the 5 feet that's already there. Now one thing also to notice is that even though Kyle's eye line is way up here and I labeled that Kyle is 200 feet from the base, all right, Kyle and his eyes are the same distance from the flagpole. So when I set this up, I can also kind of move up that 200 feet so I can have it labeled up here with my triangle. And in this case, I'm going to want to use tangent. So the tangent of 32 degrees is opposite over adjacent. And so again, to solve for x, I just need to move 200 over to the side. And so 200 times the tangent of 32 is 124.97, and that's feet. But you have to remember that that's not what it asked. It asked how tall the flagpole is. So I need to add that 5 feet to the current information, and so I get 129.97 feet is the approximate height of this flagpole. All right, so be careful that you don't just box that answer you got because you found the unknown. All right, that's why it's super important that you draw a picture so that way you can remember that you also have some extra information going along here. Now your final example is an airplane is flying at an altitude of 30,000 feet. All right, altitude is the height above the ground. All right, so again, none of these are really to scale. So that would be 30,000 feet, and that would be my airplane. All right, I draw horrible airplanes. All right. So here's my airplane. All right. And it says the angle of depression from the plane to the beginning of the runway is 12 degrees. So let's say that the runway starts. Let's kind of build where our runway is going to start. All right, let's put our runway beginning right here. All right. And so when it's talking about the angle of depression, again, that's this horizontal line. And the angle of depression is up here at 12 degrees, which again means that this angle is also 12 degrees. And it says, how far is the plane from the beginning of the runway? That is this side. So very much like the first example where you were talking about Jose is a distance to the rocket, all right? That gives you the information of the specific distance, the plane to the beginning of the runway. Pilots need to know that distance because they're approaching that section of the runway. And depending on their speed, they need to know if they need to reduce speed, increase speed. They need to make it to this point of the runway. And this is the angle that the pathway they're taking. They're not moving straight along the ground for like a takeoff, all right? So you're not given any information about this. If they wanted to know this, they would say something different. Right? So again, I'm going to be looking at the sine of 12 degrees is 30,000 over x, or x is 30,000 over the sine of 12 degrees. And so that plane is about, let's see. Wow, that's pretty big. All right, let me write this down. I've got 144,292.03 feet. Okay. All right, so that's what my calculator came up with. It's a large number, 144,000. All right. So take your time. Again, be sure that you label appropriately. You're going to have a lot of these to work on. But again, all of these are trying to find a missing side. You could do all of the same information if you were trying to find a degree measurement. If I had given you information about these two lengths and asked you for the angle of elevation or the angle of depression instead, we can use inverses. But that's your job for today.